Okay, so this time we're going to examine this graph here, the parent function of the absolute value of x. Potentially something we may have seen in this slideshow before. And we're going to talk this time though about a vertical dilation of it. So it's so when you hear dilation, if I don't know if any of you have had your eyes checked out at an optometrist, but they'll put like the little droppies in your eye, and it makes your pupils get real big. That's a dilation, but I mean that's why you might hear that word outside of this. But that means there's some sort of change happening. But let's find out what that would look like, especially with something like the absolute value of x. So, uh, let's say that our new function, is going to be 5 times p of x, the parent. So, if we look at our value of that absolute value of x, if I did x is 1, so I have my absolute value of 1. That's going to just be 1. So that's why we have the point 1, 1. But if I do the same thing with I, where that's going to be 5 times the absolute value of 1. That's going to be 5 times 1, which really is just 5. So I'm going to go to the point 1, and I'm going to go all the way up to 5 and put a little point in there. So we could just kind of repeat that process, get a couple points in there. So maybe I'll use 2. So if I went it's 5 times the absolute value of 2, let's say. That's going to be 5 times 2. And that's just going to be 10. We're going to go to 2, and then we're going to go all the way up here to 10. Now maybe let's go a little bit to the left. So if I did -1, I could go 5 times the absolute value of -1. So that's really just 5 times 1 again. And so we know that's going to be 5. We go to -1, then we go up to 5. I could also do -2. So if I did that, I'll have 5 times the absolute value of -2. But that's really just 5 times 2, which is just 10 again. So we're going to go out to -2 and then go all the way up to +10. And then just one other point, we could do 0. So if I looked at when x was 0, I could say 5 absolute value of 0, and that's just 5 times 0. So that's just going to be 0, which is the point here. So when you're looking at it, remember what we're looking at is it's a dilation. So what's happening is it's staying in the same spot, but it's getting either taller and skinnier, or it's getting shorter and wider. And so here, what you should be noticing is that instead of being way out here, now the sides of the absolute value are a lot closer. They're really close. They're really tight now. And so what that means is we have a vertical stretch, because when you stretch, you're going to get taller and skinnier. And then if it was a shrink, you would be getting shorter and wider. So when there's this number on the outside, we call that a stretch because it's going to get taller and skinnier.